The America's Cup is sailing's premier event. The competing teams must build and race the fastest 75-foot foiling monohull, a spectacular challenge of design and engineering. Accurate measurement of the boat's performance is essential. Without data, improvement is impossible. Nortek's high-performance acoustic sensors enable accurate navigation through the marine environment. Nortek leads the way in this technology across a wide range of applications, including navigation inputs for autonomous surface vehicles, AUVs and ROVs, as well as current profiles from moving platforms. Nortek's game-changing technology enabled INEOS Team UK to measure speed data with great accuracy, giving the team new insight into the boat's dynamic behavior and performance.
It derives its power from the velocity difference between the wind and the water. And sailing in the Solent, we have a fundamental problem. Measure wind speed, but we don't understand the tidal impacts of the performance of the boat. So we needed a device that let us measure accurately the speed of the boat through the water. But without that tidal information, we're a little bit lost in terms of estimating or understanding of true performance of the yacht.
We're looking for performance differences of tenths of a knot. We have to rely on that data, and it has to be 100% accurate. We trawl through acres of data from any given sailing session, and that's really how we try and evaluate the different performance in the boat and the setup of the boat. Accuracy of that data is absolutely critical.
So Nortek have given us an instrument which measures very accurately 3 components of velocity of the fluid arriving at the wing on the boat, and that's lifting the boat. And so understanding that information is critical to us backing out the true performance of the yacht.
There were 2 areas where we had to modify the Nortek speed log to enable it to work on the America's Cup boat. The first problem was speed. We're going a lot faster than vehicles that these normally travel in. They're subsea devices, they move very slowly across the seabed. So the guys at Nortek did some very clever stuff in the software to enable it to measure up to 50 knots. That was the first problem. The second was that because the subsea vehicles don't move very quickly, they don't build it for low drag. So the sensors protrude from the device, and it provides a very uneven surface through the bottom of the boat, which was completely unacceptable when we're all about trying to reduce drag to go fast. We had to build a special polycarbonate lens to fit over the transducer surface of the device, and the idea of this was that we could shape the polycarbonate very accurately to match the shape of the bulb, so it produced a completely fair flat surface. Then inside that we had to fill it with saline water so that acoustically the signal matched precisely the salt water that it was travelling through when it was measuring the speed. So remember, this is a sonic, it's a Doppler sonic device. So the polycarbonate was acoustically neutral, so was the salt water was the same salinity inside and outside of the lens. That gave us the accuracy we needed and the surface finish that we needed for the boat to perform.
So while sailing in a highly tidal environment, without that information, we could not go back and calibrate the performance of the boat against our performance predictions and our engineering calculations ahead of time. And so it's an absolutely critical part of our infrastructure.
The team at Nortek have been really fantastic to work with. You know, it's not easy getting this technology onto our foils in particular, and they've really been committed to that and worked very, very well with our team. So we're delighted with the partnership and extremely grateful.